Hello everyone, this is our first video that would be today on Thursday. What I want to do today is kind of just review a little bit of the subtraction that we did to finish up our section 3.2. And then just a little review because I know some of you guys weren't there because you were sick or had kids at home. So we'll review some of those alternate algorithms. And then we'll wrap up subtraction, and that's normally what our exam would be on. So you guys all have a review that I would hope that you would do on Tuesday. And so on Tuesday, I'm going to post the key for your review, and I recommend that you do it and keep up with it, because when we come back after this is all over, we're going to have a test on this stuff. So I want you to know how to do it. And if there's a question on it, then Zoom me, right? Zoom room it so we can talk face to face. I think that's a lot easier. And as many people that want to join in can join in on our conversation. If you're not sure how to do the Zoom room, send me a remind and I'll show you where it is on Blackboard. It's a link under the videos and worksheets on your Blackboard. All right, so I found the sheets I wanted to show you about takeaway and comparison problems. So these are some that a parent had shared with me that their kids were doing. And you can see like all of the problems, something's being taken away. So like we start off with 8 ducks, 2 swim away, they're physically gone, right? The ladybugs fly away, the bunnies hop away. So these are clearly these takeaway problems. And then the next bunch that they shared with me, to look at these. So if you read them really carefully, they're not taking away, like nothing physically is being taken away. They're just comparing. They're comparing. And so these are a little bit harder for kids to wrap their brain around, because when they think of subtraction, they think of taking away. So this was another set of papers that a mom or dad shared with me as some really nice examples of how those transition in first grade. All right, so let's just review. So I called this the mental math strategy that was used at Smith School that my kids did. So if they're given it horizontally, you want to stack it. Now normally the way we learned it, right, we'd make that into a 7 and then put this mysterious one there. What Smith School was showing the kids, and we're going to see it in Engage New York as well, is that they want this to be a multiple of 10. So if I add 5 to the bottom, I've got to add 5 to the top. And so that's going to change the problem to 87 minus 20. And then it's just a real simple subtraction problem, right? Really easy to do. I don't need to regroup. I don't need to whatever, borrow and carry over, right? It's just something that these kids can do in their heads, just mental subtraction. All right. We also did on Tuesday some problems in a different base. So I thought we may want to practice with those. So what you do for subtraction is you only represent that minuend. That's the first number of a difference problem, a subtraction problem. So we've got our 1s, our 10s, and our 100s. So we're only going to represent the first number. So we've got 4 hundreds, 2 10s, and 2 1s. And then that subtrahend, that number that we're going to take away, that's what we cross off. So this is where the regrouping comes in. So this is in base 7. I have the little 7s there. So I can't take away 6 1s. So I want to see this. I want to see you cross it off and then get in the good habits that like these kids have to do, and then regroup that. 4, 5, 6, 7. So now we can take 6 off. 1, 2, 3, 4, 5, 6. Okay, so we took care of crossing off 6. Now I want to cross off 5 longs. I can't cross off 5 longs, so I only have the 2 there. So we're going to take one of those flats and we're going to make it into 7 longs since we're in base 7. And now I can go ahead and cross off the 5. 4, 5. And then now don't forget, a lot of people sometimes forget this. They forget they still have to cross off the 2 flats. Now that one doesn't count. We use that to break that 100 into 10s. So we still have to cross 2 off. So then the difference will be 1. looks like there's 4 longs and 3 singles. So one's 43, base 7. So we played a little bit with that algorithm. And the last algorithm that we played with is called the European method. And I thought, oh, we definitely should cover that. It's kind of hard to see it in the notes to understand it. So let's say we have 412 and we want to subtract 237. It's kind of like the method upstairs where we added 5 to the top and added 5 to the bottom, but instead of doing 5s, we're going to add 10s. So if I want to take 7 away from 2, which I can't, I can easily add 10 to the top and add 10 to the bottom, but where we add the 10 is going to be strategic. So I'm going to make the 10 here and make that into a 12, and then I'm going to add the 10 down here and make that into a 47. So now I can take 7 away from 12 and call that 5. All right, same thing goes. So I can't take 4 away from 1. So it's really technically we're adding 100, we're not adding 10. So if I put a 1 up here, that changes it to 112. So where I add the 1 to the bottom will be down here for that 200. We're going to make it into 300. And then we can go ahead and do the subtraction. So 4 from 11 is 7, 3 from 4 is 1. So we've got 175. So that's kind of where we ended it, right? That's kind of where we were reviewing. We ended it right there. So let's pull out our notes. Oh, before that, I wanted to show you these. I was looking on website, or not website, Engage New York, and I found some of the stuff in 2nd grade. I was like, what? These are good stuff. So it says, solve using the algorithm. However, it says, write a number sentence for the problem modeled on the place value chart. So it must be that they wanted the kids to write down, you have 140, 1, 2, 3, 4, 5, 6, 7, 8, 48, and then they were adding to that 26. So do you see what they did? They had them group this together. This is called the disc method. You notice they don't have longs and flats. They just have discs to say I have 100 instead of drawing the flat, which is kind of nice. It's a good, nice transition. So this is not my handwriting. This is off of Engage New York. You can see they grouped the 10. You see the arrow? This is what I'm talking about. And made a 10. And then now they can go ahead and add it. So it would be 174. They also did it with subtraction. So check this out. So look, they only labeled the 42, right? And then they crossed off that 10 disc and they made the 10 singles because we're in base 10. And then what we'd have to do, like if we wanted to finish it off, so now we would cross off. Here, I'll do it. Now we'll cross off 1, 2, 3, 4, 5, 6 singles and then 2 10s. Right? So there's your solution. You have 1, 2, 3, 4, 5, 6. So then the kids would write 1, 10, 6 singles. Yeah, so this is exactly what we're doing. So this is 2nd grade, right? 2nd grade, module 4. So this is what we're doing, just in different bases, so that you can kind of understand how they're transitioning to these algorithms. So I thought, oh, that was a good find. And I found a bunch of them, but I was just going to show you. If you look online, there's a bunch of them. Do you see all of them where they're having them regroup? Ooh, there's a lot of regrouping on those ones. Okay? That's actually 4th grade. This is still 2nd grade. And there's another 2nd grade one. So just to give you kind of a feel for it. All right. So it looks like on my paper we ended somewhere around here. And oh yeah, we were playing with the arrow methods. Oh yeah, Courtney, if you're watching, you're right with this one. They did have them add 100 first. I looked. It was 100, and then the 20. So you're right. I was wrong. You got to start with 100. If you were in class, Courtney, everyone knows what I'm talking about. Courtney was right. Okay, and then I think this is where we ended it. It looks like we had some writing here. So this is kind of like that, like Smith School concept where they're adding to the top and adding to the bottom. So originally the problem says you got 451 and you want to take away 199. I'm going to turn the lamp on. I don't know if that's helpful. Oh, maybe not. All right, so you've got 451, take away 199, and this is the missing piece, right? That's going to be the solution for this missing add-in model. So they said, well, it's really hard to take away 199. So let's get this to be a power, or a multiple of 10. So if I add 1 to 199, then I have to add 1 to the 451, and I'm not changing anything. Do you see what's in blue doesn't change? So instead of saying 451 minus 199, it's going to be 452 minus 200. And then I stacked it over here. And then they don't need, it's so easy to see. It's just 252. Super easy, right? All right, so let's look at one more, and then let's look at this one because I had to add 2. Right? So here's the original model. This is what the kids would draw. So right here is the missing piece. This is their solution right there. That's what they're trying to find. So you can add 2 to the bottom and 2 to the top and not change that question mark. So instead of 432 minus 298, they're going to say it's 434 minus 300, and then it's easy to do. All right, so they were playing with one down here. Let's flip. Let's flip and see if we can find some. All right, so let's try this one. Oh, let's try this one. They already drew the box. So it covered up. The original problem would be 320 minus 190. And so this is the piece we're trying to find. This would be our unknown. So let's make this so that it's easier. I understand that this is a multiple of 10, but if we've got hundreds, we want it to be a multiple of 100. So I'm going to add 10 to the bottom and add 10 to the top. So the problem's going to change to 420 minus 200. Oh, much easier, right? I can stack that. I don't even need to stack it, right? And we just can see what it is. Not bad, right? That's not too terrible. I'm hoping you think that that's not too terrible. Oh gosh, Bryson, I don't want to start this video again. I realize I just screwed it up. Instead of 420, hold on. Oh, Bryson, I'm glad you're not here to heckle me. This should be 330. You're only adding 10, not 100. So 330. I'm not making a new video. I'm telling you, these are going unedited. Oh, I hope someone's watching this. So 330 minus 200. So then what's the answer now? I'm scared. It's going to be 130. 130, I think it's going to be the answer. So 130. All right, let's try another one. Let's try this one. Try one of these two. They kind of look the same. So you'd have the kids start off with 420 or 470, and they're going to take away the 280. I want this guy to be a multiple of 100. So I'm going to add 20. And I'm going to add 20. Okay? So then it's going to be, let's make sure I add this right, 490 minus 300. Isn't that so? I mean, you guys, I'm sure we could just stare at that and know the answer, right? We know the answer is 190. It's easy, right? So much easier than having to try to think in this where you'd have to regroup. I'm hoping that makes sense when I say it's an alternate algorithm. All right, here we go. Let's try one more. So you got, go ahead and just pause the video for a second and try it. Just pause, take a pause, then come back. I'm going to go ahead and start solving it. I'm hoping you turned it off and you solved it. And now I'm going to solve it. So did you guys add 30 to the bottom and the top? So then you'll have 560 minus 300. And then that's so much easier to do, right? So much easier to do. So 560 minus 300 is going to be your 260. I mean, I don't know if the kids need to stack it or not. Maybe as a teacher you would encourage them to stack it, but I think it's pretty easy to see it without being stacked. Are we good? I'm hoping we're good. So last time, if you remember, most of the problems, if not all of them, were from these problems that I assigned. So I highly recommend looking at chapter 2, the 3-2, and the review problems, okay, to help you out with solving some of these problems. Okay? All right. So that would end the first exam, but we still have class time left. And so what I had hoped to do on Thursday was to start dabbling a little bit, just a smidge, in these multiplication tables. Okay? I promise you'll have one of these on the final, for sure. You'll have a multiplication table on the final. It's usually always in base 5, 6, or 7. And then all of the problems on the final are either in 5, 6, or 7. Addition, subtraction, multiplication, and division. I don't know what it is. We haven't picked it yet. But let's start with the one we're used to, and that would be base 10. So we're going to fill all these in. It gets pretty lengthy when we get to base 12. So the first one I usually just put an X on because we're not going to include 0 because all kids know anything times 0 is 0. So we'll cross that off and just start with 1. And then we're going to write the digits that are left in that base, but not the 0. And then we'll start filling this in. This is a nice rule. Kids will learn very quickly that the multiplicative identity element is 1 because anything times 1 is just itself. And you guys are going to appreciate the commutative property because you guys are going to double dip to make these very, very quick when we're filling them in different bases. So for example, well, we know 2 times 2 is 4. So if we know 2 times 3 is 6, then the commutative property is going to say 3 times 2 is 6, right? 2 times 3 equals 3 times 2. Very nice, because that's going to give us a lot of quick problems. So once we solve for one, we can double dip and solve for the other when we're doing these base systems. So 4 times 2 is 10. Oh, excuse me, I'm thinking of base 5 already. Okay, 4 times 2 is 8. We're going to do base 5 next. Is 8. So then we're going to come down. So here we did the 2 times 4. So now let's do the 4 times 2. I'm going to do one more because I know you guys know these ones. So let's go 2 times 5 is 10. So then come down here and do the 5 times 2 is 10. So that the commutative property really comes out, right? I'm going to write it out. The commutative property for addition. Property for addition and multiplication are kind of the same. So addition, it was A plus B equals B plus A. For multiplication is A times B equals B times A. And then next time, I'll make sure I bring in some of those New York State assessments for 4th grade and 5th grade. Let's see if I found it. 4th grade and 5th grade. And I didn't. I'll show you the test questions that are on those. There's multiple choice, and the properties are commutative, associative, identity element, and I think distributive. So I'll show those to you so you guys can see them. All right, let's go to our friend base 5. You ready? Let's do a couple of the baby ones. So base 5. I already made the X for you because you don't need that. So then you're going to write down 1, 2, 3, 4. 1, 2, 3, 4. Now, 1 is the multiplicative identity element for any base system. So 1 times anything, it's itself. So you can knock off the first row and the first column really fast, which is really cool. All right. So there's a couple ways you can do this. Some of you are going to get really fast at it. I'm going to show you 2 ways. I'm going to show you just the thinker way, or like writing it out and regrouping, and then I'm going to show you the counting way. So 2 times 2 is 4. Doesn't matter what base system for 5 and up, right? 2 times 2 is 4. Okay. 3 times 2 is this. It's 6 in our base system. This is how many fingers it is. So how many groups of 5 can you get out of there? So there's 1 group of 5 and 1 left over. So 2 times 3 is 11. Okay, let's do the 4 times 2. So 4 times 2 is this many fingers, right? It's 8. 4 times 2. But what is it in base 5? Well, you have 1 long and 3 singles. Oh, I forgot to double dip, so let's double dip. So if we know 2 times 3 is 11, then 3 times 2 is going to be 11. Do you see? We can double dip on these. And then if 2 times 3 is, or 2 times 4 is 13, then come down here and find 2 times 4 and double dip. Isn't the double dip great? I'm hoping this makes sense. So 3 times 3, 9. That many fingers. So I got 1 group of 5 and 4 left over. So we got 14. 1 long, 4 singles. If you want to go 3 times 4, 1, 2, 3. We're going to do 4 threes. You could do this if you don't want to deal with your fingers. And so how many groups of 5? You got 1 group of 5. Another group of 5. And then 2 singles left over. So 22. And then don't forget the double dip. So then down here, 4 times 3 is 22. And the last one, 4 times 4, go ahead and try it. I'll have 16 fingers. So think, how many groups of 5 can I get out of 16? Hopefully you're saying 3. That'll be 15, and then you'll have 1 left over. So save this, because we're going to use it. We're going to use this a lot. Another way you can do these is that you can just start counting in base, whatever base you're in. This is a little bit more helpful for bigger bases, but I'm just going to show you the basics right now. So if I were to count in base 5, it would be 1, 2, 3, 4, 10, 11, 12, 13, 14, 20, 21, 22, 23, 24, 30, 31, 32, 33, 34, 40. Okay, so let's just start these. So if I were doing 4 times 2, I know that's 8 fingers. So you just have to count over 8. 1, 2, 3, 4, 5, 6, 7, 8. 4 times 2 must be 13. Do you see it? So if I say, okay, 4 times 3 is 12. So now I just need to count over 12 spots. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 times 3 must be 22 in base 5. Like you can do the counting method if you don't want to like draw it out or think about it like that. So 4 times 4, okay, 16. So I need to count over 16 of these numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 4 times 4 must be 31 in base 5. Do you see it? So let's just fill in a couple of these little baby bases. Some of them are really fast. And then we will call it a day. And hopefully you'll have some time to do that review. So let's do base 4. We'll work our way up. So base 4, the single digits besides 0 are 1, 2, and 3. 1, 2, and 3. So the first row is the multiplicative identity, so that's really easy. And the first column is really easy. Okay. So 2 times 2 in base 4, don't say 4 because 4 doesn't exist in 4, right? So what would this be in base 4? That's going to be a 10. So 2 times 3 is 6. It's this many. So how many 4s can you get out? You can get 1 4 out. Do you see there's your 4, there's your 1, and then you've got 2 singles left over. So 2 times 3 is 12. If you want, you can go like this and go, okay, I've got 2 sets of 3. I'm in base 4, so there's 1 4, and I can't group another one, so 1 long, 2 singles. Don't forget the double dip. So if 2 times 3 is 12, then 3 times 2 is 12. Double dip. Okay, 3 times 3 is 9. So I've got 1 4, 2 4s, and 1 single. So that'd be 2 longs, 1 single. Hoping this makes sense. Let's try base 3. So let's cross off that. The digits we have left are 1 and 2. 1 times 1 is 1. 1 times 2 is 2. 1 times 2 is 2. And then 2 times 2 is this many. I get 1 long and 1 single. Right? 2 times 2 is 4 singles. So I've got 1 long in base 3. And then 1 single, 11. And then this one is really crazy easy. Cross it off. 1, 1. And then 1 times 1 is 1. That's a silly base system. Are we good? So I'll show you this. I think these guys have got a lot of time on their hand, but I do want to be a member a little bit. It's called the Dozenal Society of American Multiplication Tables of Various Bases. Who wouldn't want to be a member of this? Honestly, who wouldn't? So you can see that they have all these base systems, the binary, base 2, base 3, base 4, right there. Now they went up to 10, but if you cover that up, there's our little base system. There's our multiplication table that we made. So they all the way up to, wait for it, hold on, like they go all the way up to base 26. But here, let's just check out base. I can't zoom in when it's recording. I hope you guys can see this. So do you see, like in base 12, they needed single digits. Now we used A and B. They used gamma and some other Greek letter. I don't know what that's called. Probably should look that up before I show this to you. So, but isn't that interesting? So it's 1 through 9. We would have our A, then our B if we were in base 12, and then our 10. So they made these huge number systems for base tables, for multiplication tables, all the way up to, it's crazy. They did no, oh yeah, even cooler. They did base 40. It's amazing. And wait for it. They did base 60. And do you see what base 60 is? I'm holding up because it's worth it. Hopefully you can see the word Babylonian. They made a multiplication table in Babylonian because Babylonian is base 60. Oh, I want to be a member of this group so bad. So I thought that was kind of cool. That you can see like the little carrots and the little ones. Or here, there's a carrot. You can see there's the little carrots that they made, and then the little Pac-Man-y. So I just thought that was kind of cool. All right. So anyway, I miss seeing you. Hopefully everyone is healthy. Be well. Contact me through the Remind app, or not through, well, that too, with the Remind. But if you need to see me, do the Zoom room. We can get up to 40 people on the Zoom room. Since there's only 25 in our class, that should be pretty easy to do. And I will see you next week, because Tuesday, dedicate. I know it's really hard to be diligent because I have a college kid at home too. So I try